have to turn 1, 2, 3, 4, 5 base 6 into a base 10 number. Now first we gotta talk about what this little 6 down here means. We'll circle it. That way you know which 6 I'm talking about. But by the way I said 1, 2, 3, 4, 5 base 6, you can kind of think that this is base 6, that stands for base 6. And it does, and in fact, any little small number down here, like any little itty bitty number that's like at the bottom of a regular number, that's what base it is. And well, base 10, that's the kind of system we're used to. We're raising 10 to powers, to just any powers, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and on and on and on. Well, base 10, since that's the system we're used to, we want to convert this funky number into a number that we're used to. Now, base 10, like why we're so used to it, because think about it. We're raising 10 to different powers, and it's so easy to raise 10 to powers. And if you just put a couple zeros at the end of a 1, and boom, you're done. But base 6, well, 6, that's 6 to the first, 1, that's 6 to 0. But then when you get larger and larger, it gets harder to compute all these powers of 6s than it is to compute powers of 10. But in base 10, there's 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And in base 6, there's only 6 digits. 0, 1, 2, 3, 4, and 5. Now, you might be thinking, why don't we include 6? Well, why don't we include 10 here? Well, if we include the digit 10, you'll have all these digits. How do you write digit 10? We can't say, like, we put 10 in one place. So that gives you a little, like, why we can't include 10. Well, if we can't include 10 here, we can't include a 6. You can't, like, for base 10, we can't include whatever base it is. So for anything base x, we can't include the digit x. So that's a little reasoning about why we can't include the 6 in any base. Now, another very common base is base 2, because base 2, the powers are a little easier to compute as well. The powers are pretty small, not as hard as base 6. And another reason why we know so much about base 2 is because computers use it. The computers have to use base 2 to follow our orders. But anyways, enough about that talk. Back to the problem. So we'll go after this like how you'll go after a base 10 problem. So first one up, we have 6 and a 0. Those are the 1s. But then instead of having 10s, like in base 10, we have 6s, the 6th digit. We have 6 to the first. And over here again, we have 6 squares. And then we have 6 cubes. I'm going to write this little one a little smaller. And we have 6 to the fourths. 6 to the fourths, go ahead and plop in our number. 1, 2, 3, 4, 5. But you might be wondering, how do I write 36? 36, that's 6 squared. But you can't write 36 all in one digit. Well, remember, the digit isn't the value. This is how many 6 squares there are. So we write 100 as 36. 100 base 6 is the same thing as 36 base 10. Remember, the digit is not always the value, so be aware of that. And now we just have a regular arithmetic problem. Go ahead, compute this. We got 1 a 6 to the fourths. I'm gonna go ahead and write in the extra 1. Make sure you understand this one where it came from. And we have 2 of these 6 cubes. 6 cubed. Let's see there. We got 3 of these 6 squares. squares, add, let's see, 3 of these 6 squares. We have 4 more of these sixes, I should say, because, well, 6 in the first, that is a 6, but I'll write down the first power again so that you will understand it. And of course, we have 6 in the zeros. That's 1, but I'll write 6 in the zeros anyways. Now you just have to compute this. Now, I'm going to start off from the end here, and you'll see why in a minute. So first of all, 6 to the 0, that's just 1. 5 times 1, that's 5. 6 to the first is 6. 4 times 6 is 24. It's a little off. And 6 squared, let's see, 6 squared is 36. 3 times 36. 3 times 30 is 90. 3 times 6 is 18. Add those together, you get 108. Just use a little distributive property there. And let's see, 6 cubed, I'm going to have to compute that. And now you see, while we're working from right to left, because now we know 6 squared is 36. Well, 6 cubed, we just multiply it 1 more 6. Just drop in another 6. Multiply these using the multiplication algorithm. 6 times 6 is 36. 3 times 6 is 18. And on the 3, we get 21. So that's 216. Multiply that by 2, get, see, 432. Let's see, there's 1 more 6 instead of 4. Well, this is 6 cubed. That means we kind of multiply and just drop in another 6. Multiply another 6 to get 6 to the 4th, and of course 1 doesn't contribute anything, so I can just leave it out. Let's see, 6 times 6, that's 36 again. 1 times 6 is 6, add on a 3. We have 9. 2 times 6 is 12. 1,296. Whoa. Okay, now I'm going to group these by tens here. Let's see, I'm going to take this 24, group it with the 1,296. Let's see. I'm going to use a multiplication algorithm. I'm getting stacking addition here. Go ahead, erase this. Let's see. 96 plus 24. Just try not to make a mistake here with this computation. 4 plus 6, that's 10, carry a 1. 1 plus 1 is 10, plus 2, that's 12, carry a 12. 1 plus 2 is 3, and 1 is 1. 1,320. A few more numbers. Let's see. Cross these off, group these to make another number that ends in 0. And this is 500, another 540. Well, and then we have that extra 5. Can't group that with anything because we don't have anything else. And here we have 1,865.